All right, let's talk about presentation of data for IB 4.2. This unit has a ton of stuff, so we're going to break it up into 3 individual lessons. But presentation of data is talking about graphs, analyzing graphs, data tables, central tendencies, dispersion, all that kind of stuff. We'll get into that right now. So first thing first, there are 2 types of data we have to concern ourselves with: discrete and continuous. So discrete is anything that can be counted, like the, average number of students in classes, in English classes. Got to get a working pen. And then continuous would be like, say, the average height of students. So anything that's measured is continuous. If it's counted, it's discrete. So if it's continuous, you're going to use a histogram. If it is discrete or counted, which means categorical, if it's categorical, you're going to use a bar graph. So let's talk about graphs real quick. So if you have a bar graph or any IB graph, it always needs to have a title. You need to label each axis, right? So frequency, these are going to be our categories down here, and we would put the title up there. So bar graphs, there's a gap. There's always a gap in between. They don't touch because it's not continuous data. Whereas histograms, frequency is still the y-axis, but the classes or the class widths, that's going to be the x-axis, and the bars will touch unless there's a class that has a frequency of 0, then there would be a gap. But otherwise they touch because it's continuous data. All right. And a data table that you'll often see will look like one of these 2 examples right here. So here we have our categories: small, medium, large, like small, medium, large, and 2, 4, and 3, 2, 4, and 3. Whereas if you have continuous data, you have classes and you have boundaries. So you have a lower bound and an upper bound. This is going to be a strict inequality. This is going to be a non-strict inequality. So for example, if something was exactly 4, its frequency would go in here, not here, because this is less than 4. This is greater than or equal to 4. So that's how histograms and bar graphs work. All right, so now let's talk about box and whisker plots. You most likely saw these in middle school, but I think they are worth revisiting because you have to analyze them very carefully. So this is called the spread. The interquartile range kind of describes the spread. The overall range is from the lower bound to the upper bound. What you've got with a box and whisker plot is you've got this little box in the middle and these arms. Sometimes they're set up vertically like this, but either way, you have your lower bound and your upper bound. So this is your smallest value. This is your largest value. You have first quartile, second quartile, which is called the median. We rarely call it Q2, and quartile 3 right here. So 50% of the data from the first 25 to the 75th percentile, all in the middle right here. And the median is going to be that value right there on a number line. All right, now, sometimes you have some values that are extreme, really large or really small. Those are called outliers. So it can be a little confusing. This outlier would be a part of the data set, but we still have a lower bound. And the lower bound is the smallest value that is not an outlier. And the upper bound is the largest value that is not an outlier. All right, so let's talk about quartiles, median, and interquartile range, okay? So if I've got this data set 3, 6, 8, 10, 14, 18, 24, right? The median is the physical middle. So you see how if I split it in half, I've got 3 on the left, 3 on the right. That is the physical middle. If you had an even number of points, and then you would have to take the average of the 2 middle ones. So you add them together. So number 1, number 2, add them together, and that gives you the median that way. All right. I don't know how I have so many dead pens here. Now, the median of the first half is the first quartile. The median of the second half is the third quartile. And the interquartile range is the difference between the 2. Now the overall range would be 24 minus 3, which would be 21. Right? So the range goes from 3 to 24. So the range is a distance of 21. The median is 10, first quartile 6, third quartile is 3. All right, so now let's talk about outliers. So we got this made up right here. All right? Now, there's an ugly formula, but if you understand how it works, then the formula is not that big of a deal. Basically, you've got this interquartile range. It's going to be a number like, say, 10, right? So if you have a point that is further than 1.5 times the IQR, right, past Q3, then it's an outlier. So if you have a point and it's more than Q3 plus 1.5 of the interquartile range, it's an outlier. Same thing the other way. If it's farther than 1.5 times the IQR, then it is a outlier also. So Q1 minus, right? So if it's more than 1.5 times the interquartile range away from either Q1 or Q3, it's an outlier, right? So let's see an example. Let's say our interquartile range was 10, our first quartile was at 8, and our third quartile was 18. So is 2 an outlier? Well, let's find the boundary, because let's say we have this right here. There's our bound. Let's say our boundary for the outlier is right here. If 2 is on the right side, it's not an outlier, but if 2 is on the left side, it is an outlier. So we need to figure out where this is. So 1.5 times the IQR, and we're going to subtract that from the first quartile, right? So that's going to give us 8 minus 1.5 times 10. So 8 minus 15 is negative 7. So this boundary will be negative 7. Since 2's to the right of it, 2 is closer to our first quartile than negative 7 is, so this one is no. Now, is 48 an outlier? All right, so same thing. There's like, let's say that's our leg over there. There's a boundary over here. And if it's to the right of that boundary, it's an outlier. If it's to the left, it's not. So Q3 plus 1.5 times IQR. All right, so Q3 is 18 plus, we just did this. We know that that was 15, 33. Well, 40, what was the number? 48. Well, 48 is larger than 33, so this one is an outlier. All right, so quite a bit of detail, a lot of little things to remember. You're going to have to do a lot of practice with taking a data table, making a chart. Sometimes they give you a chart, ask you for a data table, identifying the quartiles, all that kind of stuff. But this was just an overview of how it all works. Hope it was helpful. Have a good day.